Hey everyone! Welcome back to the channel. In today's lecture we're going to explore one of the most important discoveries in the history of chemistry and atomic physics. The discovery of the proton. We'll break everything down step by step in a simple and clear way, including what scientists believed about atoms before the proton was discovered, Eugen Goldstein's discharge tube experiment, how canal rays were produced, the role of the perforated cathode, how the proton was identified, properties of positive rays, differences between cathode rays and canal rays, the effect of electric and magnetic fields, important exam-style MCQs and concepts. So if you're preparing for chemistry exam, or just want to understand atomic structure better, then this lecture is perfect for you. Let's get started. Part 1. Background of atomic structure. Before the proton was discovered, scientists already knew that atoms contained negatively charged particles called electrons. J. Thomson discovered the electron using cathode ray experiments in 1897. But this created a big question. If atoms contain negatively charged electrons, then where is the positive charge coming from? Scientists knew atoms were electrically neutral overall, so there had to be some positively charged particle inside the atom balancing the negative electrons. This mystery led scientists to perform more experiments. One of the most important experiments was performed by Eugen Goldstein. Part 2. Goldstein's discharge tube experiment. Goldstein modified the cathode ray tube used by Thomson. He designed a special discharge tube that contained a glass tube, gas at very low pressure, 2 metal electrodes, anode positive electrode, cathode negative electrode, a high voltage power source. But there was one major modification. Goldstein used a perforated cathode. That means the cathode had tiny holes in it. This modification completely changed the experiment. Part 3. What happened inside the tube? When high voltage was applied across the electrodes, the gas inside the tube became ionized. Ionization means atoms lost electrons. As a result, electrons moved toward the anode. Positively charged ions moved toward the cathode. Now here's the important part. Since the cathode had holes in it, some positive ions passed through those holes and continued moving behind the cathode. Goldstein observed glowing rays behind the cathode. He called these rays canal rays, because they passed through the canals or holes in the cathode. These rays were also known as positive rays, anode rays. Part 4. Discovery of the proton. Goldstein noticed something very interesting. The nature of canal rays depended on the type of gas inside the tube. Different gases produce different positive ions. But when hydrogen gas was used, the lightest positively charged particle was produced. This particle had a positive charge, a mass much greater than the electron. This positively charged particle was later named proton. The proton became recognized as one of the fundamental particles of the atom. Part 5. Properties of canal rays. Now let's discuss the major properties of canal rays. 1. Canal rays are positively charged. Canal rays consist of positively charged particles. This was proven because they were attracted toward negatively charged plates. 2. They travel in straight lines. Canal rays move in straight paths. They can produce shadows when obstacles are placed in their path. This shows that they behave like streams of particles. 3. They are deflected by electric fields. When an electric field is applied, canal rays bend toward the negative plate. This confirms their positive charge. For they are deflected by magnetic fields. Canal rays are also affected by magnetic fields. However, their direction of deflection is opposite to cathode rays because they carry opposite charge. 5. Their mass depends on the gas used. The particles in canal rays are not always the same. Their mass changes depending on the gas present inside the tube. For example, hydrogen produces protons. Other gases produce heavier positive ions. 6. They have greater mass than electrons. Positive particles are much heavier than electrons. Because of this, canal rays move more slowly. They show less deflection in electric and magnetic fields. Part 6. Cathode rays versus canal rays. Let's compare them side by side. Cathode rays, negatively charged, consist of electrons. Travel from cathode to anode. Deflected toward positive plates. Very small mass. Canal rays, positively charged, consist of positive ions. Move toward the cathode. Pass through perforated cathode. Greater mass. This comparison is extremely important for exams. Part 7. Importance of the proton discovery. The discovery of the proton completely changed atomic theory. Scientists now understood that atoms contain negative electrons, positive protons. This discovery helped build future atomic models developed by Rutherford, Bohr, modern quantum scientists. Without the proton, modern chemistry and physics would not exist as we know them today. Part 8. Real exam concepts. Here are some important concepts students should remember. Key point 1. Canal rays are made of positive ions. Key point 2. The proton is obtained when hydrogen gas is used. Key point 3. Goldstein discovered canal rays, not the electron. Key point 4. The proton carries a positive charge equal in magnitude to the electron's negative charge. Part 9. Practice MCQs, MCQ1. Who discovered canal rays? A. Rutherford. B. Thomson. C. Goldstein. D. Chadwick. Correct answer. Goldstein. MCQ 2. Canal rays are also known as A. Cathode rays. B. Positive rays. C. X-rays. D. Gamma rays. Correct answer. Positive rays. MCQ 3. Which gas produces protons in the discharge tube experiment? A. Oxygen. B. Helium. C. Nitrogen. D. Hydrogen. Correct answer. Hydrogen. MCQ 4. Canal rays move toward A. Positive electrode. B. Negative electrode. C. Both electrodes. D. No direction. Correct answer. Negative electrode. So that's the complete story behind the discovery of the proton. Today we learned Goldstein's discharge tube experiment, formation of canal rays, discovery of positive particles, properties of canal rays, differences between cathode rays and canal rays, why the proton is important in atomic structure. If you found this lecture helpful, hit the like button, subscribe to the channel, and share this video with your friends preparing for exams. Thanks for watching, and I'll see you in the next lecture.